All right, so we have, okay, we're doing, this is actually just starting off antiderivative, so we're gonna do integration. So we're doing, just do a lot of basic integration here, and then we're gonna, towards the end of this, I'm gonna find initial conditions, okay? So what it means by initial conditions is I'm finding for the value of C, okay? I'm going to find for the value of C. So now for right here, I have to do some algebra to set up this one right here, okay? In calculus, for integration, I don't have a quotient rule. I don't have a product rule. I have other things that I use instead of that. So I have on top and bottom, right? So what I can do is I can go through and separate these because they're over a common denominator. So I could separate my pieces here. So it's going to be the integration of x over x to the 1/2 plus 1 over x to the 1/2, right? And that's going to be my dx. Now, because right here, I'm actually integrating 4x right here. So can I clean this one up right here?
Yes, sir.
So if I move my variable to the numerator, what am I going to have?
X to the negative 1/2.
Positive 1/2, right? So because I already have 1 here, right?
Oh.
So are you talking about just moving in general?
I do not know.
Okay, so yes. Yes.
You do not know the way.
So if I move this here, it becomes minus, right?
Yeah.
I'm subtracting the exponent,
You
right?
get positive x to the positive.
Oh.
Positive
that
1/2.
That one's 2 over 2.
Yes, this one is 2 over 2.
Do you know the way?
Yes, that is the way. Okay, so right here, like it's saying, I'm going to bring it up. When I bring it up, it becomes negative. So I'm subtracting my exponents. So it's going to give me the integration of x to the 1/2. And right here, it's going to become plus x to the negative 1/2 dx. So now, I cleaned it up. What's with that face? Speak.
You missed a day.
Oh, okay. All right, so now right here,
Oh, you should've came
what
up
do I
with
do? What do I do to my exponents when I'm doing integration?
You add.
You add.
Add an
Instead of
exponent.
subtract.
Add, right? So plus 1, right?
Yeah.
And so this is going to become x to the, so I'm adding 2 over 2, right?
Yes.
So it becomes 3 over 2, okay, over.
X.
Remember, now I have to put it over. I'm dividing by the 3 over 2 now, right? But if I'm dividing by 3 over 2, if I multiply by the reciprocal, so 3 over 2 as a reciprocal becomes 2 over 3, right? So 2, 3. So there's my, okay, there's my piece right there. Now, the next part, right here, I am adding again. I'm adding. So I have negative 1/2. I'm adding 2 over 2.
The 1/2.
So it gives me positive 1/2, right? So it's plus x to the 1/2, right? But now right here, it should be over 1/2, but then again with the reciprocal,
Goes.
it's just over 2, right?
No, it's not.
Yes?
Oh, it's 2. Oh, it'd be 2 over 1.
2 over 1, right? So because that 1/2, if I'm dividing by 1/2, I multiply by the reciprocal, which is going to be 2 over 1. Okay, are we okay, or am I doing too much voodoo
I know
here?
the way.
Too much.
I know the way.
Okay, do you want me to back it up on that one? Are we okay? Okay, so now, what am I missing?
C.
The C plus C.
There we go.
Big C.
Crib. Eh? Oh, I mean,
There we go.
No,
All right, so
Do you know what integration?
how do I verify that my answer is correct?
So you're going
You derive it?
Like, let's say
To verify my answer is correct,
the original.
you derive it.
take the derivative of what you have. You have skills in taking derivatives, right? You should be able to take the derivatives about just about anything now. Hey, come on now. So, you should be able to take the derivative of anything. So, to check your answer, take the derivative of this and see what we get, and it is going to work out. Okay? So, let's take a look at the next one.
Let's say they didn't do this.
No, it's because James said I have a certain set of skills, and I was like,
Now, on this one right here, you're going to have to use that certain set of skills, which is your trigonometry skills.
dang.
Now,
I never took that.
it was part of pre-calculus last year.
I was asking
Yes.
for that semester.
What are it's
Watch this. Okay, I'm going to break apart what I have.
1 minus sine.
Integration sine x over cosine x times 1 over cosine x dx. I did it like that on purpose.
Okay.
I separated because it's cosine squared is just cosine times cosine, right? Okay, so now let's see. I'm going to take the integration. So this is going to be tangent. So integration of tangent x. Now what's 1 over cosine? Secant x.
Oh, I know what you're doing. Dang.
Now, when we did derivatives, did we have a derivative that gave me an answer of secant tangent?
Tangent.
And we came up with what?
Wasn't it secant?
No, it was.
Wait.
Oh, wait, it's
Secant.
Hey, you guys tell me. You guys got flashcards for this.
Secret.
Secant. So, when I do this right here, okay?
Wow, that's kind of.
Also, it's secant plus c.
So,
Secant x plus
is it secant x plus c? Now, do you have a reference sheet on your notes?
Maybe.
Yes,
Yeah.
you do. Flip over a couple pages.
Speaking of notes, do you have an extra set? Or might have one? Oh, wait, no, I see them. They're up there.
Yes. Nice.
I thought I lost my found it.
Okay, so where are we at? We are
Over here.
there we go, right here. So secant tangent.
Wow.
There we go. Hey, there we go, right? There's a reason why I was being such a stickler about you guys going through it and memorizing these things, because you have to make it into something that you could use. We couldn't use it as this, right? We couldn't use it as this, so we have to go through making it into something else, and then from there, I get my answer. ¿Está muy fácil?
Since you went back, you didn't know if it was there.
Can we do it?
Yeah. I'm not Doran, sorry.
Okay, he's back there.
Pop the building.
I thought you were jumping.
All right, so now I asked you guys to do these, didn't I? Okay, so let's keep going with this. So we set that up. Now, the initial condition problem. Okay, what it means when it's asking for initial condition means solve for the C. So in this case right here, okay, so my function is starting with, what did I say the capital letter stands for?
It's the
Integration, right?
that one.
It's the integration of whatever I have. Okay, so it's already the integration of it. Okay, so that's the integration of whatever I have for x. Okay, do this, you only need the value of this. For one value of x, this information is called the initial condition. So we're finding for C. This initial condition here. Okay, only one curve passes to the point there. To find this curve, you could use the general solution. Okay, this, and the initial condition of this. Okay,
I get it. I get it.
so what am I doing with this information now?
Plug Chuck.
Okay, so this is going to be what? What am I writing?
Two.
Not 2.
Half of the left.
Why isn't that 2?
Four.
Isn't that the
4 equals.
Oh, 4, my bad.
Okay, and what am I plugging in for my x's?
2 to the third.
Okay.
Minus 2 plus C.
And what am I solving for here?
C.
I'm solving for the C here, right? I'm solving for the C here.
Like the basic.
So now for this case right here, this is going to be 8 minus 2, right?
6.
6, and then got to go over here, so it's going to become
Negative dos.
is equal to, there we go.
Wow.
How do you say C?
So now, we solve for the initial condition, so my function now is going to be f x equals x cubed minus x minus 2.
Or plus negative 2.
Or plus negative 2, either way. So that is my initial condition for that one right there.
I have one question.
I'll show you. Did you just
What is the capital F?
Okay, so now, you ready? So when I took a derivative, what did I do to notate it that it became the derivative? F prime. So there's my prime to actually show that I did the derivative. Okay, so now if I have f and I take the integration, it now becomes a capital F from there.
Shouldn't it just, wait, why isn't it just a regular?
Yeah, why?
Because I dropped
That's
my
the
F.
original function.
That's the original.
So
They give me the derivative.
if f is the original,
Lowercase f.
Lowercase
lowercase f is the original, right? Lowercase f is the original, capital F becomes the integration.
The C. Oh, okay.
Okay.
I got it now. I
So
understood.
it's like a different version.
So think of it like this. So if I'm starting with f of x, and I take a derivative, so derivative, what do I do with my exponents?
F prime.
I always go down, right? So it'd be f prime
What's today?
of x, then it goes
Is
f
it
double prime of
Is it
x,
today?
right? So now, but that's going down, right? Because I'm always, I'm reducing each one, right? Usually. Okay, so now for right here, but my notation for this question's for you. Come on now.
I got it.
So if I'm going to take the integration of this, my integration notation says f of x.
So
So
are we taking the integration of F?
What if you integrate twice?
okay, so now where does it say that we're taking the integration of f prime here?
Okay, yeah,
Nowhere.
you know you're right.
For this problem, I'm not.
You got me there.
On the next example, I'm going to start off with the f prime.
Can you integrate twice?
Yes, you can.
What is the symbol?
It's just, the F just gets bolder. It just gets darker and darker.
You can. It's just
You dropped
I don't
your
know.
soya.
You know, it's I know because I take multiple in, but usually when you're doing that, you're actually starting somewhere down here. So you're gonna start off with. Remember, okay, physics. What does the F double prime actually stand for? Acceleration,
Sorry, that's true.
velocity, position, right?
Oh, that makes sense.
Okay, so we usually work the other way. So if I start off with a velocity, which I think I'm going to do on the next problem, I would start off a notation like this, and I take the integration of this becomes here, right?
So what would be the
Bro, I just understood.
what would be the integration?
So what
Huh?
would that one
in
represent?
physics wise, what would be the
What
integration?
would the capital F represent in physics?
Okay, so capital F is now. When we actually doing some of this, it's talking about the area under a curve. Okay, area under a curve. So when I'm actually talking about my pieces, it's actually going to be distance traveled. If I'm talking about from my position here, I'm going to get the distance traveled. So the area under the position function is going to be the distance traveled. Okay, that's what we're trying to cover. We're getting to that, but I'm not working with the physics stuff yet.
Bro, how did Newton create this?
It wasn't Newton. It's Gottfried Leibniz,
Sorry.
and I will let you know it is on. It is. I recorded it.
You say Galileo?
You know, it's funny because we were talking about it at my college class last night in math. We were like, the guy's all Newton invented. I'm like, no, Leibniz.
Now, he must hate you.
I know, probably. All right, so right here on this problem, let's take a look. It says initial conditions and particular solution. So we're going to find one particular solution given this initial condition. Okay, find the general solution, okay, of this, and find the particular solution that satisfies right here. Okay, so for this, okay, find the general solution. That's going to give me that. So what's the derivative of e to the x?
E to the X.
E to the x. That one should be easy, right? What's the integration of e to the x?
E to the X.
So this is going to be e to the x plus c. Okay?
Equals
Supposed to equal what?
tree.
So do 3 e to the 0
Which is 1.
plus c. Anything to the 0 power is
1.
1. So what am I going to do to this?
So 2 equals c? Or c equals 2?
C equals 2.
Oh, it's a bad thing. The second. So 2 The face.
Oh.
There we go.
Wait, why is that a rule? Anything to the 0 power.
Except 0.
Because it doesn't go, you can't get it to go away. Because if it becomes 0, that actually is going to mess up your entire equations. All your equations actually are going to fail at that point.
Because I never understood that.
Wait,
either.
wait, wait.
Anything to the 0 power.
Right? So
Okay,
times
yeah,
multiplied by
he's
4.
good.
Yeah.
Well, 4 to 0. You go back, you divide by 4. Make sure.
Okay. So, right here on this one here, initial condition and particular solution. Okay, this one's a physics one. A ball is thrown upwards with the initial velocity.
Ooh.
So VI.
64 feet per second. 64 foot.
Okay, of feet per second, right? From initial height of 80 feet. What do you think that initial height is going to help me
The
solve?
initial condition.
Right?
That's our C, right? And that's our
It's going to help with my C. Okay, so I'm starting with velocity, aren't I? So how would I write this out? So in terms of t, so it would be,
F double prime?
T prime.
so it would be
V.
v of t is going to equal,
Isn't it V prime?
V of 80.
no, it's not, okay. If it was v prime, that would mean that I'm taking
Acceleration.
the derivative of v, right?
Oh,
So
okay.
watch. I'll do my so
No,
s
no.
of t. No, because I want to do this. V of t,
A of T.
a of t.
JT.
Okay, this is another way of writing this.
I meant to say S of T.
Okay,
S prime.
it's another way of writing it, but it's not writing it with my primes. It's not writing it using my tick marks to actually show that. Okay, it's just showing it is what it is, right? So, I want to check something real quick before I actually move on to the
I
next
thought he
part.
said I want you to do it really bad. Same.
Hold on one second. All right, so now, okay, we know we have a v of t given an initial condition. Okay, so my initial condition on this one right here is, so s of 0 is 80, right? And that's going to be feet. Okay? So, and we also have that we have my initial velocity. Okay, so that's going to be, so initial velocity, so that's going to be v of 0. Initial, right, is going to be what? 64 feet
Per second.
per second, right? Okay. Now, there's my initial velocity per second. Now, acceleration, what's going to happen to that acceleration?
We're going to constantly increase.
Okay, so it is increasing, right? It's increasing rate. So what's going to happen there? So now, acceleration due to gravity. Due to gravity, so I looked it up. And that's but that's going to be what? What are my units on that one?
That one's meters per second.
Meters per second.
Squared.
Squared. Oh,
Yes,
yeah.
meters per second per second. So now after the conversion that you're going to actually get, it's going to be, so my acceleration due to gravity is going to be negative 32 feet.
Per second per second.
Yes,
Negative 32 foot.
per second squared.
Because negative 9.8 meters per second.
Oh, that's
meters.
Per second per second.
Yeah.
Now, okay, so now think of it like this.
Force of gravity.
Okay, so now, if you fall off a desk.
Oh, but she just didn't know what like the 9.8 came from.
Oh, okay. If you're okay, so if you're falling off a desk, you're falling for less than a second. Okay, so your speed is going to be about 9.8 meters per second. Okay, but now that's your first second. Now your second one, it increases the same amount. So you're increasing speed as you're falling, right?
So the higher you go.
The higher you are up, the faster you go.
Until you hit terminal velocity.
Terminal velocity due to what?
Free fall.
Free
Due
fall.
to air resistance.
Air resistance,
Oh, yeah.
right?
That's how
Okay.
you go to outer space.
Yes. Okay, so now yeah. So
I don't even need to take physics. I can just take
but
this.
this is what it is. Seriously. This is applied physics for this.
I know.
So
Oh,
now,
this is a lot
because
easier.
you increase every second, they have a formula for it. That's your negative 9.8 meters per second.
There's like a
Per
formula.
second per second. So every second, you're increasing 9.8 meters. Okay? So your speed is increasing that much every second. So after 4 or 5 seconds of falling, you're going pretty fast. Okay? At about 3 seconds is enough to kill you. Okay? Just so you know, it is.
Wait, what'd you say? 3 seconds?
At about 3 seconds.
You tried it?
Okay, no, but think about it. Okay, what is 9.8 meters?
Pretty far.
How many feet's that?
32.
Okay, so let's do some rounding on this. Okay, I'm gonna do a little bit of estimation. So 1 meter, let's just say for the sake of for conversion, is 3 feet,
3 times 9.
which is
What is, can we?
27, right?
10?
So it's gonna be about 27 feet.
Oh, damn, that's the
Okay, so in 1 second you would be 27 feet. Okay, and it keeps increasing on that. So about 3 seconds, you're guaranteed a splat. Okay, you want to make a big impact? Okay, all right.
Okay.
Which equation?
Mama said to make a big impact in the world, so I just threw myself off and
Just
started
change it back. This is what we always use. The second one?
You always gotta keep your head in the
Okay, so
Bro, you kept the kinematic equations?
Yeah, I mean, why wouldn't I? I still got stuff from like first grade.
Okay, so he.
okay, so we're gonna go through and set this up.
I draw a node diagram.
Okay, I'm gonna go through and set up my function for this one right here. Where did I put my pen at? So I know,
Right, Patrick?
I know, given this, right? Yes.
You got the negative from, like, because gravity always goes down?
Yes, gravity's going down. It's pulling down. So it's going down.
I didn't forget everything about physics.
I did mine back.
32 is the conversion because we were talking in meters per second per second. Okay, but these, what are my units in? Feet. Okay, that's where we get that from.
Which direction would be negative, which would be down.
Okay, so,
But why is it 32?
okay, 9.8 meters comes out to be right at about 32. That's where we're getting that from. Okay? That's where we're going to get that from. So we know that we're going to have a couple things happening here. So my answer right here, so this one, it keeps going up right here, right? So if I'm working it backwards, remember when I take derivatives, I always take away one of my exponents, don't I? I always take away one of my exponents. So at my last thing right there, okay, it should be with this. And then every time I go up, it's actually going to add another variable for this. So I know, given that I have that, it's going to be this, right? So if I'm moving this up to here, if I move this up to here, what's going to happen? If I take the integration of this to here, what do I get?
You take the integration of the acceleration?
Okay, take the integration of the acceleration.
Negative 32.
32, but in respect to
Oh, 32t.
32t, right? Okay, so right there, that helped me out. So I have my negative 32t, right?
Yeah.
Okay, and then at this point right here, I have initial of this, so it's going to give me plus what?
C.
Okay, so I have that. So integration of my negative 32t plus 64, right?
Wow, that's pretty cool.
Okay, so we're still trying to come up here, right? So what would I do from here now? Remember, we
You go back.
add an exponent, and then divide by it, right?
Yeah, so
So negative 32.
Okay, so now I'm coming up to my s here, right?
Oh, it's negative 16.
So I add the
16
exponent and
squared.
divide by it, so it's going to become negative 16
t squared
t squared
plus 64
plus 64
t
t
Plus C.
plus c,
Which is
right? Now, okay, and so this is going to be my s of 0, right?
So that's what equals 80.
Okay, no, s of t, I'm sorry. It's not there. It's s of t.
That misses.
Sorry. Angry face. Come on, work. Okay. Come on. Okay. Equals. So there's my s of t, right? Now, I have an initial condition. It has to equal what over here?
80.
It's got to equal 80. So, my 80, and then what am I going to plug in for my t's all the way down?
0.
0. So I'm going to plug in 0 here, so that's going to give me just,
Negative 16.
Zero.
Wait, is it-
what's 0 squared?
Oh wait, 1. Oh wait, never mind.
Stop.
Hold on.
So that's going to be 0.
I'm sorry. I thought the 0 was a power.
It's alright, so that's 0. What's that?
0.
0. Okay, I have 0, 0, and then it's going to come up to be
80.
80, right?
0, 0, 0.
Okay, so now my c, for this one right here, so 80 is equal to my c value for this. So my position function, find the position function. So s of t is going to be equal to negative 16 t squared plus 64
T.
t plus 80.
That's crazy. Bro, math is so cool. When we get to the higher levels.
So we have all kinds of application happening here. Now, it also asked us, what else did it ask us?
When does the ball hit the ground?
Yes, right here. When does the ball hit the ground?
That's when H is 0.
Ooh, very good. Excellent. When does h equal 0? So I'm going to move over to the next page here. So it was what? S of t equals negative 16 t squared plus 64 t plus 80. So, the height, the position, that's what this is, the position function.
0.
And I want, when does the position equal 0? So I take this and I replace s of t with 0. So I go 0 equals negative 16 t squared plus 64 t plus 80. And we're going to find, because this is the parabola, right?
Yeah.
Just.
We can
So how many possible answers should I have? I'm going to have 2 possible answers, right?
But only one makes sense.
Only one will make sense, right?
Because the other one's in the negative time.
You should have one that's a negative also, right? So this is an upside down parabola. It's opening down, so I'm going to have 2 places for this. So let's go ahead and do some factoring.
Negative 16.
I'm going to take out that negative 16. So negative 16, and I'm left with t
I didn't do that.
squared
Minus 4t.
minus 4t
Minus 5.
minus 5, and that's equal to 0. So now, what can I do with that negative 16?
Divide it.
I divide it out, and when I divide 0 by 16, it washes out, don't I?
Yep.
So that washes out. So I'm left with, forgot that one, t squared minus 4t minus 5. Now, I'm about ready to say an F word right now.
Fact, F that.
F that.
Yeah, you F,
F
that.
that.
Nice.
F that. What is that F to?
T minus 5.
T.
T plus 1.
Minus 5 t plus 1
I think you know it's
equals 0. Now, 0 product rule here. 0 product rule.
So five?
I set each one equal to 0.
Is that 5?
So this one, if I set this equal to 0, t equals
Oh, there's 5.
positive 5 and
Equals negative 1.
t equals negative 1. So, throw away what?
the negative
Negative
time.
1.
We're not time travelers.
Okay?
Not yet.
Throw away the negative 1. So, when does the ball hit the ground?
That's 5 seconds.
5 what?
Units. Oh,
Seconds.
5 seconds.
Sorry, I forgot to give us actually. Bro, math is so cool.
First you didn't see the fact that
You could do the
You could use quadratic, or you could use the AC method, or you could do that weird X
Wait,
thing.
what's
that
the
some of
AC method?
The big X.
The AC?
Yeah.
Oh, watch this. Okay, so what's the coefficient here?
0, 1.
1. What's that coefficient?
4.
And
5.
okay, so give me 1 second. Hold on, let me stop this because
1 1000.